Hello, in this video I want to talk about the basic idea of functions. Let me start by looking at an example or two. Let's say I have a function fx equals to x squared plus 5, and say I have another function gx is equal to 2x. So if suppose that we are given x equals to 2, then the way we could use this formula is, for example, if I want to find what fx is when x is equal to 2, this is how I can write it. I can imagine substituting x into x equals to 2 into the x here, and I'll get f2 is equal to 2 squared plus 5, which is 9. Okay, so now fx is a function, and in this sense we can think of a function as a formula or some kind of a rule or some kind of a way that allows us to find a number when we are given x. So if we are given a certain value of x, this formula or a function allows us to find another value. So in a simple way, in a simple way, that's what a function is. But there are a few more details about a function that makes it a function, that comes with the meaning of a function. So we'll explore that as we go along. Now, the next thing I'd like to do is to find what is called a composite function. Let's say I've f bracket gx. I have two functions here together, the function gx and the function fx. Okay, or two formulae combined into one, and we call this a composite function. So if x is equal to 2, I can find the value of this composite function, and the meaning of this particular composite function is that I must first, for x equals to 2, I must first find gx using this formula. I must first find an answer using the function gx, which is 2x, and then I would need to pop that back into the function for f and get using this formula another answer. So let's try that. So if x is equal to 2, it means that I have f of g2x, meaning that I substitute 2 into the x here. Now, what is g2x? Okay, if I just look at this directly, g2x is when I substitute 2 into the x here, and that gives 2 times 2. 2 times 2, which is 4. So that means that f of g2x, that means the g2x is actually 4. So I can think of this as f of 4. So now I have a value for the function f, which I can then calculate using this formula, x squared plus 5. So substituting this into this formula, I get 4 squared plus 5, which is 16, plus 5, which is 21. So that's a composite function, what I get when I combine two functions together. And let me have a quick look. Let's have a quick look at this function, g minus 1. Okay, need to be careful how I write this. G written as what look like 2 to the power of minus 1 bracket x. Now the 2 to the power of minus 1 here does not actually mean 1 over this value. what it really means is an inverse function. An inverse function. So if, for example, x is 2, what does this inverse function mean? What does it mean by g minus 1 of 2? What it means is that we want to find the value. We want to find the value that would give an answer of 2 when we substitute into the x here. Okay, so what value would give an answer of 2 for this function gx? So to make this clearer, I'm going to say let this be, say, y. Okay, let this be y. So what I want to know, what this means then is that this value is the value which will give for the function g. It will give the answer 2. So that's what this means. It's a bit like we bring the g over to the other side. Okay, a bit like what we do in algebra for the inverse of a number. Okay, so in that sense, it's an inverse function. So if this is what I want, I can do it by bringing in this, using this formula here. Just substitute y into the x here. That gives 2y. So this is actually 2y is equal to 2. And once we write this down, we can see that we can solve this, and you can see that y must be 1. Okay, if you solve this, you'll find that y is equal to 1. So this gives us an answer for g inverse of 2 is equal to 1 from here. So that's an inverse function. So what I've described here is the basic thing that a function does, and the basic idea of what a composite function and an inverse function is. As I said, there are a number of details that go with this that forms an important part of what a function is. So let me look at the next idea of a function. I shall continue with fx equals to x squared plus 5. So so far I've described this formula as a way to allow us to find an answer if we know the value of x. Now this role or this job of the function is called a mapping. So a mapping is a rule or a formula that lets us find an answer if we know the value of x. So actually I can write a mapping as x. If you start from a value of x, then the formula gives you a new answer. Okay, so that's what a mapping is. It's just a formula or a rule, which is basically what this appears to do. Now, but what goes with a function? The one thing that goes with a function is that we need to specify what are the values of x that we are allowed to use. Now, usually, if we don't say anything, we would normally assume that x is just any number. And by any number, if you don't specify exactly what any number means, we would just assume that it can be any real number, like including whole numbers, decimals, fractions, positive and negative numbers. Okay, but that does not always have to be the case. We can, for example, specify a set of value. So, for example, let's say that I specify that x can be or must be a value which is between 0 and 1. Okay, I can impose this rule. I can impose this condition which says that x has to be between 0 and 1. So this is the set of allowed values of x, and this allowed value of x is called a domain. A domain. And in the same way, I can specify the allowed values, the value that I allow for the new number that I get from this formula, from this mapping. So suppose that I say that the value I would allow of this mapping is okay, say y is between 4 and 6. So that's the value I would allow of this, which I call y. And there's a name for this allowed set of allowed values. It is called the codomain. Now I can just make up a set of numbers that I allow or that I want, regardless of whether or not I would actually get all or even any of these numbers. Okay, so it's just something that I make up. So what I can now do is I can think about whether if x takes on this value, whether I actually get values that are in this codomain, or what value do I actually get. So the way to find out, a simple way to find out if we are given a formula like this would be to sketch a graph. So imagine that I sketch a graph of y equals to x squared plus 5, this one. Okay, and the domain here is between 0 and 1. So between 0 and 1, x. So this is my domain. I probably shouldn't write that name here. Let me clear this up. Okay, let's see. So this is my codomain. So this is my domain. This is my set of allowed values. I know how to plot this graph. This is a curve, a y equals to x squared graph, which is raised by 5 units. So okay, it looks like this. I think in a later video I talk more about graph sketching, but for now I'll just draw this directly. So this is what it would look like, or you could just roughly plot this by putting in some numbers into x and finding the y. So since this is the domain, that means this is the value of x that I specify, is the set of possible values of x, then it means that I should only look at the part of the graph that lies in this domain, and that goes from here to here. And here is when x is 1, if I put 1 into here, 1 squared plus 5 is 6. So the possible values of y actually goes from 5 to 6. Okay, so that's the one. So this is the part of the graph that I am interested in. Now let's take a look at this codomain. The codomain goes, that means the set of allowed values for the answer from this formula, if you like, well, is between 4 and 6. Okay, if I look at, that's the axis, or if you like, the number line for the y value for the answer in this form to this formula, and the allowed value is between 4 to 6. So between, okay, 6 is there, 4 is somewhere there. Okay, not quite to scale, but between 4 to 6 is between here and here. So this is my codomain. My allowed values of y. But the actual value that would be given by this formula, as we can see from the graph, is from 5 to 6. From 5 to 6. So this set of actual values that we can get from the domain also has a name. This set of actual value that we get is called the range. It's called the range. Okay. Now, and with this example, let me now write down, apart from this formula, let me write down a few of the features about a function which we have seen here. So one is that a function, it is a mapping. Alright, and by mapping we mean a rule that if you give it a number, it gives you another number. That's what a mapping is. Okay, if you like, it's a rule or formula that gives a number like this. Okay, now the next thing about the function is this. When you use this rule or formula to find an answer, you must get a unique answer. Alright, you must get a unique answer. So in this case, in this example, you see that I have from here this a number in the domain. If you look at this graph, okay, this graph tells me that there is a definite answer here. So in that sense, I get a unique answer. Okay, you see that the range, the possible set of the answer that I get lies inside this codomain, lies inside the allowed set of numbers for the answer. Okay. Okay, so, and it doesn't actually lie outside of the codomain. Okay, you can see that the whole of the range lies within the codomain. So this is another feature. The range lies inside the codomain.